So let's see if my clicker works. There. So the complex keyword schema format. Well, what is it? In AsyncAPI, you can, whenever you define the message payload of something, you can customize how exactly you define that payload. For example, by default, even though that you never used this keyword before, by default, it will always be this AsyncAPI schema object. Always is, and that is just the default format that the specification expects. But this keyword also allows you to define other formats in order to use the one that fits mostly within your use cases and how your organization works. So that's what I'm gonna try to cover in this presentation. I'm gonna introduce you to 3 different formats, which are a bit similar in some cases and very different in another. So I'm going to introduce those 3 formats, and then I'm going to talk a little bit about, well, how does tooling handle something like this, where you can have arbitrary schema formats and need to support all these kind of things. And then I'm also going to talk a little bit about, well, what kind of problems does this create for tooling? So by the end of the talk, I hope that at least you have learned these 3 schema formats and a bit of the pros and cons for all of them. So the 3 formats that I'm going to introduce are JSON Schema and JSON type definition and Avro. Now JSON type definition, and that's kind of our AsyncAPI schema object, because the AsyncAPI schema object is what we call a superset of JSON schema, or more specifically Draft 7. And the same is for the OpenAPI 3.0 schema object that you can also reuse in AsyncAPI. These 2 formats basically just adds extra or restricts certain functionality within JSON schema. Now, what is JSON schema? Well, in the very abstract way, it's a validation system that allows you to constrain JSON data. Now, JSON type definition, that's a bit of both how you define data, but also how you can validate data. So it has a leg in both worlds. Then we have Avro. And Avro is a type of, well, it's sold as a serialization system, and it has multiple components that I'm going to introduce as well. And in that section, we also have, for example, XSD or protobuf, which all defines the data structure. I'm going to start off with JSON schema, however, because it's the one that's most widely used within AsyncAPI and even OpenAPI. So it's important to get that foundation in place. So JSON schema. As I talked about before, through this schema format in AsyncAPI, you can define that, well, we want our payload for this message. It must be, or it's formatted using or described using a Draft 7 JSON schema format. So what is it? Well, in a very, very basic terms, as I introduced earlier, it's you validate data. You create a type of constraint on the data, on the JSON data. For example, you can have this very simple type keyword called Boolean. Now, Booleans just means that, well, all of my input data or instance data, for example, true and false, are validated against my schema. In this case, true and false both validate correctly or is valid against our schema. But something like a number 42, for example, is invalid against this schema because that type is not allowed. In JSON schema, there are basic 7 types. We have a string, which is a basic string string type. We have number, and natural numbers. Then we have integer, which are only natural numbers. And it's not possible to define only floating point numbers. That's a bit of a constraint with JSON schema. It's only possible to define whether it's number or integer. Then we have that the JSON data must be an object, for example, or an array, or Boolean. And then in the end, we have null, which is, well, we are expecting a null value. So we already introduced this type number, which accurately, or in the last case, we introduced it with Boolean. In this case, it's a number. So 42 and 42.0 are valid inputs. And true is, well, that's invalid because we are expecting a number. We can also do a union of multiple types. So this means that you can have it validate against numbers and strings. So it can both be a number, but it can also be a string. Then we have constant values. For example, if you expect that a specific JSON value to be present, you can define it using a constant keyword, const. For example, I expect there to be 42. That's the only thing that's valid as an input. We can also say, well, we also have multiple values that we accept. For example, 42, but it could also be 43, for example. So those two numbers are the only one that's valid. And everything else is not. Then we have objects. So a JSON object is just a basic object which has a property, for example, in this case, it's test, that has some value. Also JSON value, of course. The first property that we're going to look at is properties. So this one is, here we can define, well, if we encounter a property, for example, if we encounter test, it must be valid against whatever we define within here. So this means that whatever value within the test property is validated against that internal schema here. We can also say, well, if there exists a property in the JSON object as our input, what should it validate against when it's haven't been defined within properties? And that is done through the additional properties keyword. We can also pattern match, for example, where we say, well, if the property starts with a lowercase t, for example, in this case, then it must validate against whatever schema we define within here. Dependent schemas is, well, if this property is present, then it must validate against whatever is defined within here. We can also say dependent required, which is, well, if we have one property, for example, test, if that's present, then test2 must also be present. And the properties that we defined up here are all optional. None of them are required. So to set that, we use this required keyword, where we can say, well, these properties must be present within my object. We also have some further constraints that we can set. For example, well, I want to have at least one property present, or I have at maximum 5 different properties present. Arrays. We have our items keyword, which then defines, well, what are the items that are allowed within this array that they must validate against. For example, in this case, where we have a string and a number, well, then the items keyword probably contains something like a union between type string and number or integer. We can also have additional items which means that if any of the items within the JSON array does not validate against the schema that's defined within items, then we can use this additional item schema to validate those types of values. We can also say some further information about this array, which is something like you are only allowed to have unique items, or whether you are allowed to have duplicate values within the array. And the same with as we had with properties, we can have a minimum and a maximum number of items within our array. For numbers, we have something like multiple of, that the input, the JSON input must be a multiple of 2. Can also say something about whether we have minimum or maximum as a value. For example, minimum and maximum are always inclusive. So this means that it's 1 inclusive. So it can be between 1 and 5. You can also define exclusive minimum and maximums, where you exclude 1 and 5. So it can only be 2, 3, and 4, for example. And then we have strings, JSON strings. Here we can say a little bit about, well, what's the length? How many characters are we expecting this input JSON to have? And we can also say about, well, what's the maximum number of characters? We can also use one of the predefined formats for it. For example, I expect this to be an email, that this format is something that's predefined within the JSON standard that defines how an email should look like. You can also customize it to be more precise to your specific use case, what you expect, and matching it using a regex. Then we have a bunch of other keywords as well, something like all of, one of, any of, which are a way to apply subschema constraints or additional constraints to your data. For example, all of means that all of the schemas within the array must be valid. Then we have, for example, one of, which defines that, well, only one of these schemas in this array must be valid. And any of is the last one, which is, well, as long as it matches one of these schemas, then you're fine, all good. Then we also have this complex keyword called not, which is a negation of the validation result. We're going to look at that later to better clarify it. Then we have if, then, and else. Let's say that if the value of a property is a specific value, then apply a certain constraint. And then I am saying validation. So what does that even mean? Well, let's try and look at a very simple JSON schema document and an instance data. Now we have the JSON schema to the left side, and then we have our instance JSON data that it's validated again, or that's being validated to the right side. Now the JSON schema standard is built upon validating these keywords one by one by tooling. So what this means is that, well, we encounter the very first keyword, which is, well, type object. So we expect that the input data is an object in JSON. Well, we can see that it's definitely an object. So that one is valid. Then we reach the properties keyword. And this property keyword, then we iterate over all the different properties in there. So for example, we just check, well, does our input data have a display name property? Yep, definitely does. Okay, then we must validate it against the following schema here. In here, we first encounter the type string. Well, the value of the display name property is a string. So that's, of course, valid. The description is a kind of metadata information about it, and it doesn't, validation tools kind of ignore this. So this means that this entire schema is valid. And then we go over the email property because, well, do we have an email property within our input? We do. Perfect. So let's validate against this schema. And we start with the same thing as we did before with display name, type string. And that is, of course, valid. Then we look at the format email. Well, email matches against a very specific regex. And in this case, the input data or the value of email is definitely not an email. So here it marks this as being invalid. So what happens now? Well, then we mark the entire schema as for the property email as being invalid here. Okay, and that means that once it returns to the root object and there's nothing more to pass, well, we can say that the properties keyword is invalid because, well, one of the properties didn't accurately validate against our constraint. That means the entire root schema or the result of this validation is invalid. So let's try and emphasize this even more because I want to drive this. I'm using this as an example. So please don't do this in a production environment. It does nothing but create headaches. But there is specific use cases where not keywords can be very useful. But here I'm just using it as an example to really emphasize what validation means and what it means to define message payload using JSON schema. So what happens here is that we have this double not keyword, which are nested. So let's try and go through everything again. The very same thing. Then the internals of these not schema is exactly the same thing as we saw it before. So I'm just going to quickly go through it again. Well, the type object valid, display name is still valid. Then we have the email that becomes invalid. And then we go through the same thing, and now we return to our root object. Now, this entire schema is invalid. But then we reach the not keyword. And what not does is basically negates the validation results. So this means that our validation result are negated, which means that, well, this schema in here produce a valid validation result. And then we go through the last keyword, which is also a not, which again negates it. And then we have that the entire thing becomes invalid. And this is just to emphasize that you don't define the JSON structure with JSON schema or even AsyncAPI schema object. You define the validation rules that the input data is being constrained to. And we're going to look at what kind of problems that create later on in tooling. So JSON schema is really, really good at validating instance data. And it's really good at creating these runtime constraints on our data. For example, if, else, and even, well, if this property is present, then the other property must be present as well, etc. But for generating data models, because in AsyncAPI, well, if you use spec first approach when you design your APIs, it means that you use JSON schema to describe the constraints of the data, but you kind of don't want to manually create these data models that represents the data format for your message. And we're going to look at that later. Next up, we have Avro. Yes, so Avro. So Avro is, well, it's a definition language. You define the data types here. And it has a little bit of special perspective, if I can call it that. So in AsyncAPI, you can define this using this schema format, where we define it as an Avro and we're using version 1.9. Now, Avro is sold as a system that comprises of multiple components. It's mainly used for serializing and deserializing data. And that's one of the strong suits. Now, within this system, we have multiple components. And these components are, for example, the schema formats. That's the one I'm going to introduce today. And then it also have the possibility of creating something like request response calls and other types of information within Avro. I'm going to leave that out though. So we also have an interface description language, more tuned towards developers, as it's more similar with common programming languages. And then, of course, we have the serialization and deserialization part. It has both serialization and deserialization to and from bytes, but also to JSON. And that's kind of the thing that I'm going to mainly focus on. So the schema format is defined using a basic JSON, same as JSON schema, that's also JSON. And we start with some very basic types. We have null, which is, well, no value. Then we have a Boolean, which is, well, a binary value. Then we have an integer, which is a 32-bit signed integer. And then we have a long, which is, well, 64-bit. Then we have floating and double, which is single and double precision floating points. And then we have bytes, which is a sequence of 8-bit, 8-bit bytes. Then we also have string, which is, well, is just a sequence of characters. And here it defines that these are the data formats. This is not validation rules that we saw in JSON schema. This is what the structure of the data is. It also has more complex types. For example, we can have unions even, where, well, it's one of multiple types. We can also have enums, which is, in the basic terms, is just constant set of string values that you can have. We also have arrays, where you, through the items keyword, can define the structure of the entries within this array. Then we have maps, which is a single schema. So the values, you can only define what the value type is. The key for the map is always strings. So in this case, it's, for example, well, the values of this map is long or double precision, 62-bit integer. Then we have records, which is something that's very similar to the JSON object, but you can also think of it as you can think of it as an entry within a table or a row within a CSV file. So that's the record. And yeah, here you can define certain fields, for example, username, email, same as we saw with JSON schema, that has the type string. Now, to map the Avro types to or the fields within a record, to map that into JSON types and examples, we can, for example, see that, well, a a record is an object, and it's it's a JSON object. Enums is just a basic string character that's constant. We also have array, and array can of course be one of multiple types. And in the end, we have something called fixed. And fixed it's just a fancy word of saying that it's a bite-sized type to represent something like MD5 hashes. So Avro is really good when you want to generate code, for example, and when you want to serialize data models from those generated codes. But it's not great at validating data in more a constrained way that JSON Schema is. And yeah, then we have a type of in the middle of the two formats that we got introduced. We have JSON type definition. Now, JSON type definition is it describes the shape of the JSON data. For example, we don't have in AsyncAPI, we don't have a specific format listed as that you can use for JSON type definition. But it doesn't really matter that we define it from a standard perspective, because you can always use custom keys here, and tooling you can make the tooling understand it. There are some keywords that I'm not gonna go too much into details. We have some is a type nullable. We can also have references and even some extra data that you can define using the metadata keyword. But let's look at the basic types. We have, and you can see these are very similar to the Avro types. We just have a few additions. For example, something like a timestamp type. And we also have a more fine-grained control of the size of the integers. JSON type definition has these type of forms. Now, forms are basically just, for example, in this case, an empty form, which are rather easily mapped into a programming language. For example, for TypeScript, it's any. For Java, it's this generic object type. And then we also have values, which are for defining a map of key value types. Then we have elements, which are basic lists. And then we have enums, for example, where it's also just only string values. And then we have the properties form, which are this, it's for objects in JSON, where you can define, which kind of properties exist there. All properties are by default required. And then you can use optional properties to define, optional properties. And you can, of course, also define if none of these match, are there any additional properties that you allow in your format. And JSON type definition is, it's really good at generating code, but it's also, it also has tooling for validating the data, even though that is a definition format. And this kind of leads me back to, these are the different, at least in different types, where we have validation tool or validation schema, and then we have a definition language, and then we have a little bit of in between both. And yeah, tooling. How the hell do we handle this? In the parser, for example, it's possible to always define, or it's always possible to define a custom schema parser. For example, how do you parse a message that has that matches this schema format? Then you can create some custom formatting logic and adapt the message object to be more accessible. I actually don't. Give it a second. No, okay. I can't remember how much time I have left, so let's see. Problems, I said. Yes. So we have a few issues with this feature. Mainly it's because when you describe a message payload, are you really aware that you're defining validation rules if you don't define anything? And even the consumers of the document, like if you read the documentation for this, it's not clear to me that it provides any value of only reading what the data can validate against. When if you try to interact with the API, well, don't you want to know the structure of it? But it's kind of difficult, right? Because you can't have, at the moment at least, it's not possible to have the best of both worlds, where you both have the definition of the structure and the validation rules. And this is a bit of a problem. And especially for code generation. How do you generate code based on this schema here, where you have the double negation? You can, of course, expect to have something like this interface type payload, our model. But yeah, I see that we didn't have. It could also be something like classes. What else? And well, we all know programmers are really stubborn and like the way their thinking is. So they want their format, they want their types that they think should be there. And there's nothing within, for example, JSON schema that enables you or helps you create these type of data models. And I think I'm going to skip this because I think I'm out of time, right? Yeah, I think so. Or at least right at the edge. So yeah, thank you for listening in, and I hope you got the introduction to the different schema formats and how they can be used and what some of the problems is for them.